Chapter 6, Part 1 of Airplane Flying Handbook, Volume 1. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by Bruce Kachuk. Airplane Flying Handbook, Volume 1 by Federal Aviation Administration. Chapter 6, Ground Reference Maneuvers, Part 1. Purpose and Scope. Ground reference maneuvers and their related factors are used in developing a high degree of pilot skill. Although most of these maneuvers are not performed as such in normal everyday flying, the elements and principles involved in each are applicable to performance of the customary pilot operations. They aid the pilot in analyzing the effect of wind and other forces acting on the airplane, and in developing a fine control touch, coordination, and the division of attention necessary for accurate and safe maneuvering of the airplane. All of the early part of the pilot's training has been conducted at relatively high altitudes, and for the purpose of developing technique, knowledge of maneuvers, coordination, feel, and the handling of the airplane in general. This training will have required that most of the pilot's attention be given to the actual handling of the airplane and the results of control pressures on the action and attitude of the airplane. If permitted to continue beyond the appropriate training stage, however, the student pilot's concentration of attention will become a fixed habit, one that will seriously detract from the student's ease and safety as a pilot, and will be very difficult to eliminate. Therefore, it is necessary, as soon as the pilot shows proficiency in the fundamental maneuvers, that the pilot be introduced to maneuvers requiring outside attention on a practical application of these maneuvers and the knowledge gained. It should be stressed that, during ground reference maneuvers, it is equally important that basic flying technique previously learned be maintained. The flight instructor should not allow any relaxation of the student's previous standard of technique, simply because a new factor is added. This requirement should be maintained throughout the student's progress from maneuver to maneuver. Each new maneuver should embody some advance and include the principles of the preceding one, in order that continuity be maintained. Each new factor introduced should be merely a step up of one already learned, so that orderly, consistent progress can be made. Maneuvering by reference to ground objects. Ground track or ground reference maneuvers are performed at a relatively low altitude, while applying wind drift correction as needed to follow a predetermined track or path over the ground. They are designed to develop the ability to control the airplane and to recognize and correct for the effect of wind, while dividing attention among other matters. This requires planning ahead of the airplane, maintaining orientation in relation to ground objects, flying appropriate headings to follow a desired ground track, and being cognizant of other air traffic in the immediate vicinity. Ground reference maneuvers should be flown at an altitude of approximately 600 to 1,000 feet AGL. The actual altitude will depend on the speed and type of airplane to a large extent, and the following factors should be considered. The speed with relation to the ground should not be so apparent that events happen too rapidly. The radius of the turn and the path of the airplane over the ground should be easily noted, and changes planned and effected as circumstances require. Drift should be easily discernible, but not tax the student too much in making corrections. Objects on the ground should appear in their proportion and size. The altitude should be low enough to render any gain or loss apparent to the student, but in no case lower than 500 feet above the highest obstruction. During these maneuvers, both the instructor and the student should be alert for available forced landing fields. The area chosen should be away from communities, livestock, or groups of people to prevent possible annoyance or hazards to others. Due to the altitudes at which these maneuvers are performed, there is little time available to search for a suitable field for landing in the event the need arises. Drift and ground track control. Whenever any object is free from the ground, it is affected by the medium with which it is surrounded. This means that a free object will move in whatever direction and speed that the medium moves. For example, if a powerboat is crossing a river and the river is still, the boat could head directly to a point on the opposite shore and travel on a straight course to that point without drifting. However, if the river were flowing swiftly, the water current would have to be considered. That is, as the boat progresses forward with its own power, It must also move upstream at the same rate the river is moving it downstream. This is accomplished by angling the boat upstream sufficiently to counteract the downstream flow. If this is done, the boat will follow the desired track across the river from the departure point directly to the intended destination point. Should the boat not be headed sufficiently upstream, it would drift with the current and run aground at some point downstream on the opposite bank. See Figure 6-1. As soon as an airplane becomes airborne, it is free of ground friction. Its path is then affected by the air mass in which it is flying. Therefore, the airplane, like the boat, will not always track along the ground in the exact direction that it is headed. When flying with the longitudinal axis of the airplane aligned with the road, it may be noted that the airplane gets closer to or farther from the road without any turn having been made. This would indicate that the air mass is moving sideward in relation to the airplane. Since the airplane is flying within this moving body of air, wind, it moves or drifts with the air in the same direction and speed, just like the boat moved with the river current. See Figure 6-1. When flying straight and level and following a selected ground track, the preferred method of correcting for wind drift is to head the airplane, wind correction angle, sufficiently into the wind to cause the airplane to move forward into the wind at the same rate the wind is moving it sideways. Depending on the wind velocity, this may require a large wind correction angle, or one of only a few degrees. When the drift has been neutralized, the airplane will follow the desired ground track. To understand the need for drift correction during flight, consider a flight with a wind velocity of 30 knots from the left and 90 degrees to the direction the airplane is headed. After 1 hour, the body of air in which the airplane is flying will have moved 30 nautical miles, nm, to the right. Since the airplane is moving with this body of air, it too will have drifted 30 nautical miles to the right. In relation to the air, the airplane moved forward, but in relation to the ground, it moved forward as well as 30 nautical miles to the right. There are times when the pilot needs to correct for drift while in a turn. See Figure 6-2. Throughout the turn, the wind will be acting on the airplane from constantly changing angles. The relative wind angle and speed govern the time it takes for the airplane to progress through any part of a turn. This is due to the constantly changing ground speed. When the airplane is headed into the wind, the ground speed is decreased. When headed downwind, the ground speed is increased. Through the crosswind portion of a turn, the airplane must be turned sufficiently into the wind to counteract drift. To follow a desired circular ground track, the wind correction angle must be varied in a timely manner because of the varying ground speed as a turn progresses. The faster the ground speed, the faster the wind correction angle must be established. The slower the ground speed, the slower the wind correction angle may be established. It can be seen, then, that the steepest bank and fastest rate of turn should be made on the downwind portion of the turn, and the shallowest bank and slowest rate of turn on the upwind portion. The principles and techniques of varying the angle of bank to change the rate of turn and wind correction angle for controlling wind drift during a turn are the same for all ground track maneuvers involving changes in direction of flight. When there is no wind, it should be simple to fly along a ground track with an arc of exactly 180 degrees and a constant radius, because the flight path and ground track would be identical. This can be demonstrated by approaching a road at a 90-degree angle, and, when directly over the road, rolling into a medium-banked turn, then maintaining the same angle of bank throughout the 180 degrees of turn. See Figure 6-2. To complete the turn, the rollout should be started at a point where the wings will become level, as the airplane again reaches the road at a 90-degree angle, and will be directly over the road just as the turn is completed. This would be possible only if there were absolutely no wind, and if the angle of bank and the rate of turn remained constant throughout the entire maneuver. If the turn were made with a constant angle of bank and a wind blowing directly across the road, it would result in a constant radius turn through the air. However, the wind effects would cause the ground track to be distorted from a constant radius turn or semicircular path. The greater the wind velocity, the greater would be the difference between the desired ground track and the flight path. To counteract this drift, the flight path can be controlled by the pilot in such a manner as to neutralize the effect of the wind and cause the ground track to be a constant radius semicircle. The effects of wind during turns can be demonstrated after selecting a road, railroad, or other ground reference that forms a straight line parallel to the wind. Fly into the wind directly over and along the line, and then make a turn with a constant medium angle of bank for 360 degrees of turn. See Figure 6-3. The airplane will return to a point directly over the line, but slightly downwind from the starting point, the amount depending on the wind velocity and the time required to complete the turn. The path over the ground will be an elongated circle, although in reference to the air it is a perfect circle. Straight flight during the upwind segment after completion of the turn is necessary to bring the airplane back to the starting position. A similar 360-degree turn may be started at a specific point over the reference line, with the airplane headed directly downwind. In this demonstration, the effect of wind during the constant bank turn will drift the airplane to a point where the line is re-intercepted, but the 360-degree turn will be completed at a point downwind from the starting point. Another reference line which lies directly crosswind may be selected and the same procedure repeated, showing that if wind drift is not corrected, the airplane will, at the completion of the 360-degree turn, be headed in the original direction, but will have drifted away from the line a distance dependent on the amount of wind. From these demonstrations, it can be seen where and why it is necessary to increase or decrease the angle of bank and the rate of turn to achieve a desired track over the ground. The principles and techniques involved can be practiced and evaluated by the performance of the ground track maneuvers discussed in this chapter. Rectangular course. Normally, the first ground reference maneuver the pilot is introduced to is the rectangular course. See Figure 6-4. The rectangular course is a training maneuver in which the ground track of the airplane is equidistant from all sides of a selected rectangular area on the ground. The maneuver simulates the conditions encountered in an airport traffic pattern. While performing the maneuver, the altitude and airspeed should be held constant. The maneuver assists the student pilot in perfecting practical application of the turn, the division of attention between the flight path, ground objects, and the handling of the airplane, the timing of the start of a turn so that the turn will be fully established at a definite point over the ground, the timing of the recovery from a turn so that a definite ground track will be maintained, the establishing of a ground track, and the determination of the appropriate crab angle. Like those of other ground track maneuvers, one of the objectives is to develop division of attention between the flight path and ground references, while controlling the airplane and watching for other aircraft in the vicinity. Another objective is to develop recognition of drift toward or away from a line parallel to the intended ground track. This will be helpful in recognizing drift toward or from an airport runway during the various legs of the airport traffic pattern. For this maneuver, a square or rectangular field, or an area bounded on four sides by section lines or roads, the sides of which are approximately a mile in length, should be selected well away from other air traffic. The airplane should be flown parallel to and at a uniform distance about 1/4 to 1/2 mile away from the field boundaries, not above the boundaries. For best results, the flight path should be positioned outside the field boundaries, just far enough that they may be easily observed from either pilot's seat by looking out the side of the airplane. If an attempt is made to fly directly above the edges of the field, the pilot will have no usable reference points to start and complete the turns. The closer the track of the airplane is to the field boundaries, the steeper the bank necessary at the turning points. Also, the pilot should be able to see the edges of the selected field while seated in a normal position and looking out the side of the airplane during either a left-hand or right-hand course. The distance of the ground track from the edges of the field should be the same regardless of whether the course is flown to the left or right. All turns should be started when the airplane is abeam the corner of the field boundaries, and the bank normally should not exceed 45 degrees. These should be the determining factors in establishing the distance from the boundaries for performing the maneuver. Although the rectangular course may be entered from any direction, this discussion assumes entry on a downwind. On the downwind leg, the wind is a tailwind and results in an increased ground speed. Consequently, the turn onto the next leg is entered with a fairly fast rate of roll-in with relatively steep bank. As the turn progresses, the bank angle is reduced gradually because the tailwind component is diminishing, resulting in a decreasing ground speed. During and after the turn onto this leg, the equivalent of the base leg in a traffic pattern, the wind will tend to drift the airplane away from the field boundary. To compensate for the drift, the amount of turn will be more than 90 degrees. The rollout from this turn must be such that as the wings become level, the airplane is turned slightly toward the field and into the wind to correct for drift. The airplane should again be the same distance from the field boundary and at the same altitude as on other legs. The base leg should be continued until the upwind leg boundary is being approached. Once more, the pilot should anticipate drift and turning radius. Since drift correction was held on the base leg, it is necessary to turn less than 90 degrees to align the airplane parallel to the upwind leg boundary. This turn should be started with a medium bank angle with a gradual reduction to a shallow bank as the turn progresses. The rollout should be timed to assure paralleling the boundary of the field as the wings become level. While the airplane is on the upwind leg, the next field boundary should be observed as it is being approached to plan the turn onto the crosswind leg. Since the wind is a headwind on this leg, it is reducing the airplane's ground speed, and during the turn onto the crosswind leg, will try to drift the airplane toward the field. For this reason, the roll-in to the turn must be slow, and the bank relatively shallow to counteract this effect. As the turn progresses, the headwind component decreases, allowing the ground speed to increase. Consequently, the bank angle and rate of turn are increased gradually to assure that upon completion of the turn, the crosswind ground track will continue the same distance from the edge of the field. Completion of the turn with the wings level should be accomplished at a point aligned with the upwind corner of the field. Simultaneously, as the wings are rolled level, the proper drift correction is established with the airplane turned into the wind. This requires that the turn be less than a 90-degree change in heading. If the turn has been made properly, the field boundary will again appear to be 1/4 to 1/2 mile away. While on the crosswind leg, the wind correction angle should be adjusted as necessary to maintain a uniform distance from the field boundary. As the next field boundary is being approached, the pilot should plan the turn onto the downwind leg. Since a wind correction angle is being held into the wind and away from the field while on the crosswind leg, this next turn will require a turn of more than 90 degrees. Since the crosswind will become a tailwind, causing the ground speed to increase during this turn, the bank initially should be medium and progressively increased as the turn proceeds. To complete the turn, the rollout must be timed so that the wings become level at a point aligned with the crosswind corner of the field, just as the longitudinal axis of the airplane again becomes parallel to the field boundary. The distance from the field boundary should be the same as from the other sides of the field. Usually, drift should not be encountered on the upwind or the downwind leg, but it may be difficult to find a situation where the wind is blowing exactly parallel to the field boundaries. This would make it necessary to use a slight wind correction angle on all the legs. It is important to anticipate the turns to correct for ground speed, drift, and turning radius. When the wind is behind the airplane, the turn must be faster and steeper. When it is ahead of the airplane, the turn must be slower and shallower. These same techniques apply while flying in airport traffic patterns. Common errors in the performance of rectangular courses are failure to adequately clear the area, failure to establish proper altitude prior to entry, typically entering the maneuver while descending, failure to establish appropriate wind correction angle resulting in drift, gaining or losing altitude, poor coordination, typically skidding in turns from a downwind heading and slipping in turns from an upwind heading, abrupt control usage, inability to adequately divide attention between airplane control and maintaining ground track, improper timing in beginning and recovering from turns, inadequate visual lookout for other aircraft. End of Chapter 6, Part 1.